of them.
Achai. How are you? Your voice doesn't seem fine.
Yeah,
Salman,
yeah, voice is quite different, but yeah, okay.
you're fine.
Yeah, I'm fine.
You're fine. Okay, fine. That's good. Okay, fine then. So I think we are done till Bronsted-Lowry acid-base concept, right? Hamza, what happened?
Yes, I'm still finding it, sir. I don't know where I kept that.
Okay, fine. Class कीजिए आपको फिर like you should have kept it before the class. खैर, no problem. We have tomorrow also. You can bring them tomorrow. But again, you will get more homework today. Okay, you will get more homework today. So let us write the advantages of Bronsted-Lowry concept. है ना, Bronsted-Lowry हुआ था ना आप लोगों का तो. Hope so. Effect of pressure, and then we did something. Ionic equilibrium. Okay, Bronsted-Lowry acid-base concept. For strong acid. Okay, fine. Strong base. We have done that. Right. Next, advantages of. What happened to you, Hiba? You did all those questions? Yes or no? Yes, Hiba.
Yes, sir.
No problem in those questions?
No, sir.
Okay, fine. Advantages of Bronsted-Lowry concept. Okay, so in Bronsted-Lowry concept, what happens? That it also explains the basicity of some of basicity. It also explains the basicity of a few bases which do not have OH negative ions, right? Not all bases have OH negative ions. For example, NH3, Na2CO3, these don't have any OH negative ions, and Bronsted-Lowry concept is able to explain the basic character of these species. So, right, it explains basic character of NH3, Na2CO3, Na2CO3, etc., which don't have OH negative groups, OH minus groups, which don't have OH minus group. Second one, it is not limited to molecules. It is not limited to molecules. It can also comment on the basic character. Basic character of what? Of ions. Basic character of ions. For example, we can say that NH4 positive is acidic in nature. Why? Because it has a tendency to lose. It has a tendency to lose proton. So this is an ion, and Arrhenius concept was not able to tell anything about ions. Right, the third one, it explains acid-base concept in non-aqueous medium 2. In non-aqueous medium 2. Okay, if you look at the Arrhenius equation, Arrhenius concept said that if you put a species on water, then what does it do? Does it liberate H plus or does it liberate OH negative? So Arrhenius concept was dependent on water. Okay, that was only for the aqueous medium. Bronsted-Lowry concept, it has nothing to do with the medium. It is just saying something about the species. Whether you put it in water or ammonia, it doesn't matter. If it is abstracting a proton, that means it is eating up a proton, that means it is a base. If it is giving proton, that means it is a acid. It is an acid. Okay, so write these 3 points. Let me know if you are done. Raise your hand if you're done. Okay. Acha, I did not ask Nehra. Nehra, how are you? Yes, Nehra. Okay, Nehra is done. Hiba is done. Oh, Nehra, are you there? Can you hear me? Okay, waiting for Khalid and Salman. Yes, Nehra, are you there? Can you please turn the mic on or send something in chat at least? Okay, Salman, Khalid are also done. Okay, this is really bad. What happened, Nehra? You can't unmute. You can't send anything in chat. If you are sending chat, now then send it to Salim, not to Chem MEB. Okay. Yes. So, did you do any questions? Yes or no? Any doubt? No doubt. Okay. That means you have sent the assignment if you have no doubt. Okay. You have sent an assignment. Equilibrium constant and its application. This is previous, I think. Okay, fine. Write the next one. Limitations of the Bronsted-Lowry concept. Limitations of what? Limitations of Bronsted-Lowry concept. First point is that it does not explain it does not explain the acidic and basic characters. Acidic, character of non-metallic oxide and basic character of metallic oxides. Okay, metallic oxides. For example, if you see calcium oxide, and if you react this with SO3, it will give you an acid-base reaction and it forms salt CaSO4. And since CaSO4 is salt, that means this one of these should be a base and the other should be an acid. So this CaO, this is a metallic oxide, it is a base. This is an acid, right? And this is a salt. So CaSO4, right? CaSO4 is forming. So it does not explain because here we don't have any protons. So how can we explain it from the Bronsted-Lowry concept? Okay, we cannot explain it from the Bronsted-Lowry concept. That is why this is a limitation of Bronsted-Lowry concept. Second point, it does not explain the acidic character. does not explain the acidic character of substances with incomplete octet. Okay, with incomplete octet. For example, BF3, BCl3, AlCl3, and etc. So write these 2 points in the limitation. Then we will move on to the Lewis concept. Khalid, are you done? Yes, Khalid, are you done? No. Okay,
Done,
maybe
sir.
disconnect. Done. Okay. Right. Next, Lewis concept of acid base. Acid and base. Okay. So Lewis made things very simple. He made things very simple. He said that acids are those electron pair acceptors. Okay, they accept pair of electrons. What will acid do? Acid will accept pair of electrons. Okay, that means these are electron pair acceptor. Then what are bases? Bases are opposite. They are electron pair donors, or they donate. What they will do? They will donate pair of electrons. That means these are electron pair donor. Okay. So there will be an acid. There will be a base. This base should have an unshared pair of electrons, right? Which is not shared. And what does it do? It has to give this pair of electron to A. Now, as soon as it gave, so this B became base. And if A accepted, it became acid. And they can form a bond that is AB. Okay, they will form AB bond. So he generalized all the reactions, and in this way, you can say that all of these reactions are what? All of the reactions are flow of electron from one species to another. So we can categorize everything into an acid and a base, right? So first of all, we will look at Lewis base and how to identify them. So right, Lewis base. So there are two main criteria on identifying. At least there, I mean, there is essentially one. There is essentially one, but you can make two. You can make a distinction. You can say that neutral species right? Neutral species with lone pair of electron. With lone pair electrons, right? So for example, there can be many examples. NH3, right? NH3 has a lone pair. What else has a lone pair? H2O has a lone pair. No, this H2O has a lone pair. Then RNH2 will have a lone pair. What will have a lone pair? ROH will have a lone pair. Right? ROH will have a lone pair. So all of these are what? Neutral species with lone pair. These are Lewis spaces. And what are another type of Lewis bases. These are anions. And as soon as I said anion, that means obviously there should be a unshared pair of electrons, because negative charge it will be only present if you have some electrons. So if I write Cn negative, that means there's a lone pair here. There's also a lone pair in the carbon atom. Okay, there's also a lone pair in the carbon atom. If I write Cl negative, then there are 4 lone pairs on chlorine. If I write OH negative, then there are 3 lone pairs on oxygen, right? So essentially there should be a lone pair electron. If you have to identify a Lewis base, then it should have a unshared pair of electron. It should have a unshared pair of electron. So please write this down. Let me know if you're done. Then we will look at the Lewis acids. Let me know if you're done. Okay, I think most of you are done. Okay. Right, next, that is Lewis acids. And we can categorize Lewis acid into 4 different classes, okay? Into 4 different classes. So the first ones are which have incomplete octet. They will have incomplete octet. That means they will have less than 8 electrons in their octet. So examples of these will be BF3. As you can see, only 3 bond is present, no lone pair is present, and it has 6 electrons. Similarly, AlCl3. You can also write FeCl3. So these all of them they will have incomplete octets. Another example would be of simple cations. Another example will be of simple cations. Okay. So if you are a cation, you are a simple cation, then obviously you are going to accept electrons, right? You're going to accept electrons. So on the stronger side will be Ag positive, H positive, right? So the D block elements, the metals of D block, H positive, these are what? Stronger Lewis acid, because they can accept pair of electrons. But if I talk about the alkali metals and the alkaline earth metals, since they have a tendency to lose electron, so they are more comfortable if they have a positive charge. If I compare them with the Ag positive and with H positive and the cations of D block elements. So on the lower end and the weaker end, I can write sodium positive. Yeah, it is a Lewis acid, but it does not have much tendency to accept electron as H plus and Ag positive. Okay. Also, you can talk about Ca2 positive, right? Ca2 positive. Next in the list we have the empty d orbitals. If there is empty d orbitals, okay. Empty d orbitals. So for example, SiF4, SnCl4, PF5, right? So these are the molecules of the group 3 and beyond. And after group 2, you will have the empty d orbitals present, and in that they can accept some electrons, right? So if the d orbitals are empty, that means they can accept a pair of electron in the d orbitals. And the last one is atoms which are connected to electronegative element via multiple bonds. Atoms connected to more electronegative atom via multiple bond. Okay, so these are also Lewis acids. For example, SCO2, then you can have SO2. These are the examples in which carbon atom is the atom which can act as a Lewis acid and it can accept a pair of electron. We can also write some examples. Okay, we can also write some examples. I will show you two examples which are of your use. First is the BF3. So you have boron and 3 fluorides, plus you have NH3. So here there is a lone pair electron and there is a empty p orbital in boron. Empty p orbital in boron. Why? Because you know that is 1s2, 2s2, right? 1s2, 2s2 and 2p. How much? 2p is 1. So even if you promote the electron, it should be 2s1 and 2p2, like this. Right. So these are the 3 orbitals which will take part in the hybridization. They will form 1-1 bond with fluorine, and this is the p orbital which is vacant. Right. So nitrogen can dump its lone pair electrons on the empty p orbital here, and you are going to get a molecule which is something like this, in which we have boron which is connected to 3 fluorines, and there is a coordinate bond in which the nitrogen is completely giving the electrons to boron, and it is also sharing it, right? So first of all, it is donating and then it is sharing. So this is a reaction in which Lewis acid, since it is accepting electrons, it is a Lewis acid. BF3 is the Lewis acid, NH3 is the Lewis base. And one example from the CO2 molecule, we have carbon double bond oxygen, double bond oxygen. So if I react this in presence of an acid, that is, let us say, no, sorry, this is already an acid. We'll have to react this with in the presence of a base, let us say OH negative. So in this case, what happens? This oxygen, it has many lone pairs. One of the lone pair will attack on what? The carbon atom, because we know this will be delta negative, this will be delta negative, this will be delta positive. So this oxygen atom will attack on the carbon atom, and it will lose a bond with oxygen like this. And then oxygen is going to abstract the hydrogen from the OH. Okay, it is going to abstract. So first of all, what you will be making is C double bond. Oh, sorry. Here you will be having C double bond O, and there will be CO negative, and there will be a OH group that is attached here. Okay, OH group attached here. So this is how CO2 can act also as CO2 can also act as acid. Write this down. Let me know if you're done. Then I will give you a question, and you have to identify which of the following are Lewis acids and bases. I hope you have written the above part, yes or no?
Yes, sir.
Okay. Hamza is done. Okay. Okay, I guess all of you are done, right? Seems so. Okay, fine. Let me know if you're not done. Okay, write the question. Identify Lewis acid and bases in following. Done, guys?
Yes, sir, done.
So tell me, OH negative is what?
Sir, base.
Okay, Lewis base. F negative,
Base.
Lewis base. H positive,
Lewis acid.
Lewis acid. Okay. BCl3,
Lewis acid.
Lewis acid. H2O,
Lewis base.
Lewis base. SO3,
Lewis acid.
Lewis acid. Okay, so I think you are telling Lewis acid. Fine. Why
Yes,
Lewis
sir.
acid? Why? Why? What criteria does it fit? Tell me.
It accepts electrons.
अरे नहीं तो criteria, the 4 criteria ना, which so it can be placed in which of these classes?
So the last one.
The fourth one,
Yeah, 4th one and also the this one, right? The 3rd one, empty d orbital. Correct. Yes, sir. Because sulfur, it is in which, it is in which period? Third period, right? Third period, that means it has d orbit. So it can fit on both of these things. The fourth criteria and also the third criteria. I'm happy that you also remember the structure of SO3 that will have a multiple bond. Right, guys? I hope you remember it. Yes or no? नहीं
Yes,
याद था
sir.
ऐसी तुक्का लग गया अच्छा याद था. Okay. So if I will summarize these concepts, then we have looked at acid and bases and 3 definitions. So we have acid and we have bases. Okay, acid and base. So 3 concepts. The first concept was from Arrhenius. So what did Arrhenius say? Arrhenius said that an acid is something that will give H plus in water, right? It will give H plus in water. What is base? Base will give OH negative in water. Then who came along? The next was, who was next after Arrhenius? Bronsted-Lowry. Yes or no, guys? What happened? Yes or no? Bronsted-Lowry, na? Bronsted-Lowry. So in Bronsted-Lowry definition, acid is something that will give you H plus, right? So H plus donor. And base is H plus acceptor. Next, who is next? Next was Lewis. So what did Lewis say? The Lewis concept. Lewis concept said that acid is electron pair acceptor. And what is a base? It is an electron pair donor. Okay, so this is a simple thing that you can always remember. Okay. You can write this down. Let me know if you're done. Done, guys?
Yes, sir. Done.
Okay. Write some remarks. So in remarks, the first point that you'll write is all Arrhenius acids are.
Sir, could you tell the spelling of Arrhenius?
ARRHENIUS. हम एक बार लिख देते हैं सही से, ठीक है? I hope this is helpful, Khalid.
Yes, sir. Thank you.
Okay. All Arrhenius acids are Bronsted acids, but all Arrhenius bases are not Bronsted bases. The example is more important, and you can remember this with example. That is NaOH. For NaOH, I can say that For any OH, I can say that yes, it is what? It is a Arrhenius base, है ना? Because it will give, है ना? It will gives OH negative. What it is, it can't give, or rather I should say it can't accept H positive, right? Because NaOH, it does not accept H positive, and that is why not a Bronsted base. Okay, this is important. It is not a Bronsted base. So all Arrhenius acids are Bronsted acids, but all Arrhenius bases are not Bronsted bases. Next point is that, write the second point. All Bronsted bases are Lewis bases. Or all Bronsted bases are Lewis base, but all Bronsted acids are not Lewis acid. Okay, for example, if I talk about HCl, then what is happening? It is giving me H3O plus, it will give me H plus Cl negative, right? Now, in this particular case, this HCl, it is an acid, but it is not accepting any electrons, right? It is not accepting any electrons. It is just getting dissociated. So this HCl, and therefore not a Lewis acid. So write this down. Let me know if you're done. Okay, Nahra is done. What about others? Hamza, Hiba, Khalid, Salman. Hiba is done. Okay.
Done, sir.
Done. Hamza done?
Yes, sir.
Okay, fine, done. So now we have looked about acid and bases and everything. Now we have to add acid on water. We will add base in water. Then we will talk about the concentration, not in qualitative term that OH negative will be higher or H plus will be lesser, not like that in exact term, right? You have to now start calculations and all. Because again, I hope you know that we are going to calculate, we are not going to measure. We are not going to measure what is the concentration of acid or a base. That is what is the concentration of H plus and OH negative at equilibrium. Because we can't, I mean, there are devices, but again, it is based on calculations only, and then only we were able to get some devices. Okay, so we will calculate those. We will calculate those things, and first of all, I want to make it clear that we will only be mostly dealing with, rather I should say, we will be mostly dealing with the Arrhenius acid base concept. Okay, so acid is something for us right now that gives H plus, and base is something that will give me OH negative if I put that thing in water. Okay, there will be a few cases we will see in which we will be drifting away from the definitions of Arrhenius. But as of now, we will be dealing and calculating and doing all the experiments on the definition of Arrhenius. That is, an acid is something that gives H plus, base is something that gives OH negative in water. OH negative in water. Where? Water. So first of all, we need to study water, right? So this is the system in which all the changes are going to happen. So this is the system that we have to study first of all. Now in this system, we also know that there are H positive that is made up of HOH, right? It is made up of HOH, and hence we have to study what are the concentration of H plus and OH negative in this water system, and what is going to happen if I will add some acid or if I add some base. Okay, if I add some base. So starting with water. So don't write anything. And let me just write a self-ionization, we say this, of water. So we will have water as a liquid, another water molecule as a liquid. And we can also show that there is an acid-base reaction. And it can form H3O positive. One of the H2O will act as acid, the other will act as a base. It will form H3O positive in aqueous medium as it is an ion. Plus it will form OH negative again in aqueous medium as it is an ion, right? An aqueous medium. So we are taking one of the H2 as acid, the other as base. And for this particular equilibrium, we can write a equilibrium constant. And also we know that it is a weak electrolyte, right? It is a weak electrolyte because it does not conduct electricity. Pure water does not conduct electricity. So you guys will help me in writing the K. Tell me guys, what will be the K? Equilibrium constant for this reaction. Concentration of product, na? Please start. Concentration of
H3O.
H3O positive into concentration of
OH negative.
H minus.
OH negative. OH minus divided by the concentration of H2O square. Yes or no?
Yes, sir.
Yeah. Okay.
Yes, sir.
But we also know that this is liquid and H2O square. And if I want to calculate now, if I see, have I discussed this? Why do we not take the concentration of a pure liquid or a pure solid with you guys? Did I? अच्छा, let us calculate ना concentration of H2O. Wait a second. ये पता नहीं, आप लोग तो ऐसे शांत हो जाते हैं. Okay, I have given you some questions. By convention, we write this. Na? We have written this. By convention, we take it as unity. You have said this. Okay, fine. Now, let me tell you what happens actually. Okay, let me tell you what happens actually. I want you to calculate the concentration of a solution that is A and it has water, only water. Okay, it has only water. So it has how many mass of water is here? 200 grams. Okay, and that means the volume will be how much? The volume will be 0.2 liters, right? 200 ml. Yes or no? Tell me, guys.
Yes,
कोई
sir.
तो बोलो, है ना? 1 gram per ml, and in this case we have 100 gram, and similarly the volume will be 0.1 liter, right? So these are the two. Water. Okay, here we have only water. So if I see, you can see that there is a decrease in amount of water. But does this decrease in amount of water also corresponds with the decrease in the concentration? Let us see that. If I calculate the number of moles of A, and I divide this by the volume, it will give me the concentration. So number of moles of A is equal to how much? 200 grams divided by 18 gram per mole. That will give me the number of moles divided by 0.2. Yes or no, guys? Tell me. Yes or no?
Yes, sir.
And NB upon volume will give me the concentration of this bucket B, in which we have 100 grams, right? So here we will be having 100 grams divided by 18 gram per mole divided by 0.1 liters. Now, if you want to solve this, you will get 200 divided by 18 into 0.2, and here you will be getting 100. Yeah, 100 upon 18 into 0.1. There will be moles. Here will be liters. Here also will be mole, and here there will be liters. And we can cancel this as 0.1 and this as 100. Yes or no? Tell me, guys. Tell me.
Yes, sir.
So this, both of these things are equal, na? Tell me.
Yes, sir.
Right? These things are equal. That means even if there is a decrease in the reactant, even if there is a decrease in this reactant molecule, there will be no difference in the concentration, because if the amount of water is decreasing, the amount of any particular liquid is decreasing, there will be a decrease in volume, and hence the concentration is going to be a constant. The concentration is going to be a constant. So we can write this as H3O positive into OH negative divided by a constant, because the square of a constant will again be a constant, and this is what? K. Now I will multiply this constant to this constant, and I will write K into constant. It is equal to the concentration of H3O positive multiplied by the concentration of OH negative, and when I multiply the equilibrium constant and and the concentration of water squared, I will get a new constant, and I will call this as Kw. Because I have multiplied the concentration of water, I am calling this as Kw. Okay, I'm calling this as Kw, and this will be equal to H3O positive multiplied by OH negative. Write this down. Let me know if you are done. And you will write the topic as ionization constant of water, or you can write self ionization of water. Self ionization of water or auto ionization of water. There are many names for the same phenomena in which water molecule in itself, it breaks down into H3O positive and OH negative and OH negative. So write this down. Then we will talk about the Kw. We'll talk about the Kw. Done, all of you? Hamza, okay, Hamza is done. Khalid, Salman, Nehra, Hiba, guys done? Okay, Hiba is also done. Yes, Khalid, Salman, Nehra. Okay. Fine, you can lower your hand. Now write with me. Kw. Kw is equilibrium constant multiplied by the concentration. So equilibrium constant is a constant. Concentration of water is also a constant, and hence Kw is a constant. But what is Kw known as? Kw is AKA is known as what? Ionic product of water. Kw is an equilibrium constant, and hence depends on temperature. Hence depends on temperature. Kw, it is equal to exactly equal to 1.008 into 10 to the power minus 14 mole square liter inverse square. Okay, so this is the exact value of the Kw at 298 Kelvin. You have to specify the temperature also, and we have to specify the temperature also. But we will remember that Kw, no matter what, whether we are adding acid, whether we are adding base, the Kw is going to be same. The Kw it is going to be 1 into 10 to the power minus 14. Okay, 1 into 10 to the power minus 14. You can forget about this, but you cannot forget about 1 into 10 to the power minus 14 or just 10 to the power minus 14. Kw is 10 to the power minus 14. नींद से उठा के आपसे कोई पूछे what is Kw, you have to answer 10 to the power minus 14 at 298 Kelvin. At 298 Kelvin. This is an information that you cannot afford to forget. You can put a 10 star here, but don't forget it. Okay. Kw, it is equal to 10 to the power minus 14. And also, no matter what, we know that we have done this, right? We have done this in the previous class, that in ionic equilibrium, if I am adding the acid, okay, we have done acid and bases, weak electrolyte, strong electrolyte. Okay. Okay, so we will today learn what will happen if I add acid and what will happen if I add a base. Okay, if I add a base. Now, so we know that Kw, it is equal to 10 to the power minus 14 no matter what, and it is temperature dependent. And also you can say that Kw increases. That means it will change according to temperature, increases with increase in temperature. It is directly proportional to temperature. Now, if I write about a pure water, I can also write the autoionization of water as like this. Liquid can get autoionized into H plus plus OH negative. And in this case, when we have pure water, we can say that number of H plus molecules and molecules are going to be equal, because if one molecule breaks, it will form one H plus and one OH negative. If two breaks, it will form two H negative and two H plus ions, right? So in pure water, the concentration of H plus, it is equal to the concentration of OH negative. And let us take this concentration as X. We know that Kw, it is equal to the concentration of H plus into the concentration of OH negative. And since we have taken both as X, I can write that 10 to the power minus 14, it is equal to, for X, for H plus, I'm writing X, and again for OH negative, I will write X. Other than I can just write X square, and hence I can write X will be equal to 10 to the power minus 7, right? Yes or no? Root of 10 to the power minus 14, 10 to the power minus 14's root. This will be equal to 10 to the power minus 7. Now, we all know there is mole square, liter square. So mole square's root will be mole, liter inverse square roots will be inverse, right? This is X. What does this mean? That means in pure water, the concentration of H plus, it is equal to the concentration of OH negative, which is equal to 10 to the power minus 7 moles per liter. 10 to the power minus 7 moles per liter. Write this down. Let me know if you're done. This is important that only in pure water, okay? Only in pure water. Done, guys? Let me know if you're done.
Done, sir.
All of you done? Yes or no? Yes, guys, done.
Done, sir.
Okay. Next thing, as you can see that in 1 liter, okay, in how many liters? In 1 liter, we can see that in 1 liter of H2O, that means 1000 grams of H2O. That means 1000 upon 18 grams per mole. That is equal to 55.55 moles, right? Now you have this many, this many moles of water, and how many H plus are there? How many H plus are there? There is 10 to the power minus 7. That means 0.000. 10 to the power minus 7 moles now. Let me write 10 to the power minus 7 moles. That means into 6.022 into 10 to the power 23. This will be equal to 6.022. 6.022 into 10 to the power how much? 16, right? This is the number of molecules of H plus. And if I compare this with water, the undissociated water, the concentration of undissociated water is how many moles? It is 55 into 6. And let me just keep it 6 into 10 to the power 23 into 10 to the power 23. So can you see the difference? The difference is of almost 8th power. The difference is almost of 8th power. Okay. So we can say that, we can confidently say that if I look at this equilibrium H2O getting dissociated to H plus and OH negative, whose Kw is equal to 10 to the power minus 14, right? It is 10 to the power minus 14. It is very less than 10 to the power minus 3. And we know from the second lesson of this chapter, the second class, that if the Kw is less than 10 to the power minus 3, then only reactants will be there and very less number of products will be there. Yes or no, guys? You remember this? We classified it into 3 types. K, it is what? Greater than 10 to the power 3. K is less than 10 to the
Yes,
power
sir.
minus 3. Yes or no? In between. So it is less than 10 to the power minus 3. And hence we can say that there will be reactants present predominantly, and undissociated water will be, the equilibrium will be lying towards undissociated water. You can write the next point. Write with me. Since undissociated, so you can write it like this. Since the, oops, wait a second, let me reshare this thing. You can write since Kw is very small, the equilibrium will lie towards undissociated water. Done, guys? You write this one point, then we will understand something else. We will understand what is going to happen if I add H plus or we remove or we add OH negative. Okay, if we add H plus or we add OH negative. Done. This one line.
Yes, sir.
Done. Okay, fine. Now all of you listen and tell me, answer me. I have H2O.
Sir, could you scroll up again? Sorry.
Yeah, sure, no problem. Yes. Just write the start point. Since Kw is very small, the equilibrium will lie towards undissociated water. Done?
Done, sir.
Okay. Now I'm talking about water, that is H2O, and it is in equilibrium with H plus and OH negative. H plus and OH negative. Now tell me, what will happen if I increase the amount of, please listen very carefully, if I increase the amount of the human, it is increasing the amount of H plus ions. Tell me guys, what will happen? What will the system do? It will shift the reaction forward or backward, because human is changing the state of the system, right? Now tell me guys, first of all, identify if I am increasing H plus ion, then I am increasing the products or I am increasing the reactants, and then you can answer me. Please see and tell. If I increase the H plus ions, what will happen? The reaction will move forward or backward. Okay, tell me what I am increasing. We are increasing the product or we are increasing the reactant?
Product.
Okay, so if I'm increasing the product, what will the system try to do? It will try to minimize the change, yes or no? It will try to minimize
Yes,
the
sir.
change. Okay, it will try to minimize the change. That's what. So that means if I'm increasing H plus ion, the system will try to decrease this. Yes or no? Will system will try to decrease it? Yes or no?
Yes, sir.
Okay. Now system can move either forward or backward. So if it is moving forward, it is creating H plus. Yes or no? If I move forward to the
Yes,
reaction,
sir.
that means what the system will do? System will move backward in order to consume H plus, right? To get less and less number of H plus. So if I increase the H plus ion, this will result in a backward direction shift. Reaction will move backward. Don't write these points. Just listen. Just listen. Okay, backward. So we have understood this point. Okay, we have understood this point. Now let us see what happens. Now let us see. Acha, wait a second. If I am increasing the H plus ions, please listen very carefully. If I am increasing the H plus ions, that means the reaction will go backward. The reaction will go backward. Okay. Now, if the reaction will go backward, I have increased H plus ions, right? I have increased H plus ions. I did not do anything with the OH negative ions. So while going backward, OH and negative ions will also get consumed. Yes or no? Tell me. Tell me. OH negative ions will also get consumed because the reaction is going backward. No or yes? अरे what happened guys? I'm asking something नहीं समझ में आ रहा आप लोगों को? ये समझा? I can't hear you.
Yes, sir.
Achha, so what did I say? If the reaction will go backward, what will happen?
Sir, the H plus ions will get consumed.
And OH negative ions will also get consumed, yes or no?
Yes, sir.
Wait a second. What do you mean by yes, sir? You are just agreeing or you understand why? Achha, the reaction will go backward. That means H plus and OH negative, they will combine, yes or no?
Yes, sir.
Yes, no? Okay, fine. Achha, let me give you example. I was thinking of not using numbers, but we can use numbers. No problem in that. Okay, no problem in that. Now, I'm not considering H2O because the concentration is of no use for us. I am just using H plus and OH negative. So initially, if I have pure water, then this will be 10 to the power minus 7 molars. This will be also 10 to the power minus 7 molars. Any problem here? Tell me guys, any problem?
No, sir.
Then I added 9 into 10 to the power minus 7 molars of H plus. So this is 1 into 10 to the power minus 7, right? And I did not add anything in the OH. So what is I have changed something. The change will be what? I have added something, right? I have added something. So we will get, so 10 to the power minus 7, I can take that as common. 10 to the power minus 7, I have taken that as common. And this is what? 1 plus 9. Yes or no? Tell me guys.
Yes, sir.
Understand this much maths? Okay. So this will be 10 into 10 to the power minus 7, which will be equal to 10 to the power minus 6 molars. Tell me, any problem till here, guys?
No, sir.
Hamza, Hiba, any problem? Salman, Khalid?
No, sir.
No problem, na? Okay, fine. That means this is not equilibrium. This is the change, and this is the change. And in the change, what do we calculate? In the change, we calculate the Q. So what will be the Q? Q will be the concentration of H plus and the concentration of OH negative, right? The concentration of H plus is how much? 10 to the power minus 6, yes or no? Into 10 to the power minus 7. Tell me, guys, yes or no?
Yes, sir.
So this will be equal to how much? Tell me, 10 to the power minus. This will be 10 to the power minus
1.
1.
No, wait. That's the 13, yes.
Minus 13. क्या हो गया आपको? Okay, this is Q, and what is K? K, it is equal to 10 to the power minus 14. Yes or no? Tell me.
Yes,
K
sir.
is a constant, na? And we can see that KW. This is KW. Okay. So Q is what? It is greater than KW, and this is also one of the criteria for backward reaction. Fine. So there will be backward reaction. Now we have to see how much change will be there. Okay. How much change will be there? Okay. Now, please listen. Don't write. We have again H plus and OH negative. H plus and OH negative. Now we will take that the concentration of H plus is 10 to the power minus 6, OH negative is 10 to the power minus 7. Reaction is going backwards, right? So reaction is going backward this side. So that means for both of them, reaction is going this side backwards. That means there will be decrease in the concentration of H plus of X amount. And if 1 mole of H plus is reacting, it will react with 1 mole of OH negative. If 2 moles is reacting, it will react with 2 moles of OH negative. If 100 moles is reacting, it will react with 100 moles of OH negative. And if X moles of H plus is reacting, it will react with X moles of OH negative. Any problem, guys? Tell me. No problem? Are guys, tell me yes or no? No problem, na? Till here, any problem? Khalid?
No,
Salman?
no problem.
No problem. Okay, fine. That means at equilibrium, I can say 10 to the power minus 6 minus X. This will be the concentration of H plus, and 10 to the power minus 7 minus some amount X. This will be the concentration of OH negative. Yes or no, guys? Tell me.
Yes, sir.
Okay, fine. Now this is very crucial. Now you have to tell me which of them is higher, the 10 to the power minus 6 minus X or 10 to the power minus 7 minus X. Which is greater?
The 10 to the power minus 6 minus X.
Yes, this is greater, right? This is greater. Okay, this is greater. That's fine. This is greater. Now we can see that H plus is what? H plus is the concentration of H plus. It is greater than 10 to the power minus 7. Yes or no? The concentration of OH negative, it is less than 10 to the power minus 7. Yes or no, guys? Tell me.
Yes, sir.
Now, this is very important point that I am pretty sure you would not have thought about when you were learning about acids and bases. So when we learned about acid, we just know it increases the concentration of H plus. Yeah, it does, but it also decreases the concentration of OH negative. That is important. It also decreases the concentration of OH negative. And the important thing is that the decrease is of the same amount, right? So OH negative and H positive. So the concentration of H positive is increasing. The concentration of OH negative will decrease if I am adding an acid. Is this point clear to everyone? Yes or no? Please tell me. And I hope that this is not something very intuitive about acids. Yes or no? This is the new thing that you are learning in 11th standard that is different from the 10th standard acid-base concept that whatever you have learned in 10th standard or 9th standard. Is this clear with everyone? Yes or no?
Yes, sir.
What does acid do? Acid not only increases the concentration of H plus ions, it also decreases the concentration of OH negative ions. And what does it lead to? So if there is increase in the concentration of H plus, there's a decrease in the concentration of OH negative, then the Kw will be concentration of H plus into the concentration of OH negative. This is increasing, this is decreasing. That will keep the Kw as constant, and that is why all in the case of acids also 10 to the power minus 14. Got this point? Yes or no? Tell me. Got this point? Yes or no? Tell me.
Yes,
Kw
sir.
will still be 10 to the power minus 14 because even if I'm increasing the concentration of H plus, it is decreasing the concentration of OH negative, and hence the multiplication, the product is going to be constant. Okay. So, right, next, addition of acids and bases in water, and the first is addition of acid in water. Point number one, it increases the concentration of H positive and decreases the concentration of OH negative. Second point, concentration of H positive is greater than the concentration of OH negative. This is the criteria for if a particular system is acidic, then we will look at the concentration of H plus and the concentration of OH negative. Concentration of OH negative. Third point, Kw is equal to 10 to the power minus 14. It does not change. Kw will be Kw even if the solution, even if a system is in acidic condition. Okay, even if we have added acid in that, Kw is going to remain constant 10 to the power minus 14, and hence we can say I can calculate this is equal to what? This is equal to concentration of H plus and the concentration of OH negative. So if I am telling you I have added this much this much moles of H plus, I have added this many moles of H plus, it means that I'm giving you the concentration. From concentration of H positive, I know this concentration of H positive. I know that this is a constant, and I can calculate the concentration of OH negative. And hence, in an acidic condition, if you want to calculate the concentration of OH negative, this will be equal to the Kw divided by the concentration of H positive that will be given. If you're adding an acid, you should be knowing how much acid am I adding. This will be equal to 10 to the power minus 14 divided by the concentration of H positive. Okay, so these are the 4 points, and the most important point is this one. Never forget that. Okay, never forget that. This is the new term that I said now. We will be learning about initial change and equilibrium. So about equilibrium, we know many things. We know Kc, we know Kp, we know the total pressure. In ionic equilibrium, we are introducing a new constant, that is Kw, and that is going to help us in the calculation of the equilibrium concentration of acids and bases, and particularly concentration of H plus and OH negative. Okay, concentration of OH negative and H positive. Right, next, addition of bases. In water, become like, so first point will be it increases the concentration of OH negative and decreases the concentration of H positive. In this case, the concentration of OH negative is greater than the concentration of H positive. But again, remember the third point, Kw is still 10 to the power minus 14, and it is the product of the concentration of H plus and the concentration of OH negative. And in this case, if we are adding a base, we will know the concentration of the base, and from that concentration of base, we can calculate the concentration of H positive, and this will be equal to the Kw divided by the concentration of OH negative. This is equal to 10 to the power minus 14 divided by the concentration of OH negative. Right, these 4 points, let me know if you're done. Then we will talk about the pH scale. Then in pH scale, we will learn about log. Okay, and log ke baad aaj ki class done, then we will meet tomorrow. Write this down.
Sir, could you show the first point of addition of
Yeah,
acid?
sure. Yeah. समझ में आया सबको? Yes or no? Tell me.
Yes, sir.
Yes, okay, this is very important. Okay, this is very important, and this particular first line is very important. Please keep that in mind. Okay, we are no longer in 10th standard, and this one line is either going to help you in ionic equilibrium, and if you forget this line, you will be always stuck in questions. You will be always thinking, if I'm adding acid, then why the Kw is 10 to the power minus 14? Then always remind yourself, if I'm adding acid, the concentration of H plus is increasing, but the concentration of OH negative is also decreasing. Because I know from 9th standard, from I don't know whether whenever you started learning about acid, there was only talk about H plus, and if you talked about bases, there was only talk of OH negative, right? But both of these things are happening. We're increasing the concentration of H plus, decreasing the concentration of OH negative if I'm adding acids in water. If I'm adding as bases in water, then I'm increasing the concentration of OH negative and decreasing the concentration of H positive. I will say this so many times that this should be your standard line if you talk about acids and bases. Okay, acids concentration increases of H plus, decreases of OH negative. Write this down. Let me know if you're done. So equilibrium chapter, and mainly ionic equilibrium, is problematic due to unlearning. You have to unlearn a few things, right? So there is the point where the student face some difficulty. Okay, Hiba is done. Hamza is done. Waiting for Khalid, Salman. Okay, Nahra is also done. इक्विलिब्रियम हुआ आप लोग के स्कूल में?
Yes, sir.
ये बात पता थी?
I guess no.
हाँ, तो थोड़ा अपने दोस्तों का आप हेल्प कर सकते हैं. There are a few things that I will tell you. Don't tell to the friends. But this is something that I want you can tell everyone. Okay, and if you are able to make somebody understand, then that will be inherited, like that will be in your brain for a very long time. Okay, so concepts, you can, whenever I teach a concept, and then you can make anyone understand about that concept, any of your friends. But if I tell you something about remembering that, memorizing ke bare mein, if I give you some trick for memorizing, don't tell anyone that. So memorizing I'm very particular about, but concepts I can give my concepts. Okay, not my concept, because these are not my concepts. You can give the concepts of acid and bases to your friends also. Okay, so done, all of you. Let me write about the pH scale. You may have heard of pH, right? 1 to 14, acid is before 7, bases is after 7. But I'm more interested in the log part that you are going to learn in 11th standard. So write pH scale. I will not be writing many things about pH scales because I hope you have seen those things. But for me, what is important is the definition of pH. pH is the negative logarithm of molar concentration of H3O plus ions. This is important. Which concentration? Molar concentration of H3O plus ions. That means mathematically I can show pH is equal to minus log of concentration of H3O plus. The molar concentration, they are shown in square brackets. Okay, whenever you have square bracket, that means just giving you the molar concentration, and the base is 10. We'll understand about all of these things. So let me know if you're done writing this, then we will talk about logs. Also write one more, that pH is equal to 1 upon, sorry, rather it should be log 1 upon the concentration of H3O positive. You can also write the concentration of H plus is equal to 10 to the power minus pH. Okay, so these three formulas you write by heart, this formula and this formula. Okay, you by heart these two formulas, very important. More importantly, this one, you'll be always asked to calculate the concentration of H plus ions, because there are many devices which can measure the pH. Okay, which can measure the pH. And also if you're looking at anything which is remotely acidic or basic in the ingredients of a particular, not something that you eat, but something that you use, then there will be pH given, and from that pH you can you have to calculate the concentration. Okay, you have to calculate the concentration. So let me know if you're done till here. Then I will talk about logs. How many of you are comfortable with logarithm and you can calculate the log of something or anti-log of something? Tell me, guys. No one. Is there anyone who is comfortable? Then I can ask him some questions and then we can move forward. No.
So like the simple logarithmic questions.
Mm-hmm.
Yeah, I can solve some.
Log table के साथ with log tables. Or you can simplify the log expressions. I think you can do that, huh? So what is log of base 10? Log of 100 to the base 10? Can you evaluate that? Hamza?
Yes, sir.
Log of 100 to the base 10. Done, guys, all of you?
So 10.
Yeah. Log of base नहीं log of base 10 अच्छा ठीक है. I start with this only, है ना? Because I'm not a mathematician, है ना? I'm a chemist, so I will have to start from somewhere between, है ना? I cannot start. I can start, but I don't start with why do we need logs, है ना? So फिर हम वहाँ से start करते from addition. So I go from addition to multiplication to exponents and then to log, but I won't go there. I will start with a simple expression that you can always remember. I start with a definition of log to the base 10. अच्छा ऐसे करते हैं ना, बता देते हैं आप लोगों को.
Sir, it's 2, right?
Yes, tell me.
It's 2.
हाँ 2 है, 2 है. Okay. So we have this expression, right? And those who have biology, na, they please listen very carefully. So Hiba, you have biology?
Yes, sir.
है ना? तो देखिए हम I will tell you what is the use of log and where did log come from. Okay. So there are 3 different numbers. Yes or no, Hiba? What are they? The 3 different numbers in this equation? What are 3 different numbers here? Yes, Hiba. You can't see 3 different numbers. Are there is 10,
Yes, sir. 10, 2,
10,
and 100.
2 and 100, right?
Yes, sir.
10, 2 and 100. Okay. So if I will talk about 100, if I say what is 100, then I can express 100 in terms of 10 and 2. I will say it is 10 to the power 2. Yes or no?
Yes, sir.
Okay. If I ask about 10, what is 10? Then you can express this in the terms of 100 and 2. You will say that it is the root of 100. Yes or no?
Yes, sir.
So I can say 100 is 10 to the power 10 raised to 2. Okay. And I can talk about 10 is the 10 is 100 raised to 2 inverse or 1 by 2. Yes or no? Yes or no? Tell me. हाँ गाइस, नहीं रूट ही पता है क्या आप लोग को? रूट का मतलब हाफ
Yes,
होता
sir.
है,
Yes.
पता है ना? 10 is root of 100 है ना? That root means 1 by 2. I can also say what is 2. क्वेश्चन उठता है कि नहीं उठता? हिबा बायो वाले बताइए आप. हिबा टेल मी, द क्वेश्चन अराइजेस ना, व्हाट इज 2?
Yes,
Yes,
sir.
Hiba, what is 2? You tell me. So at this point of time, can you say that math has some gap? Yes or no? There is some gap in the math. Yes or no? Tell me. See, you can do this with any equation, okay? If you have equation which has 3 numbers, na, you can do this. You can express, for example, A plus B equals to C. So we can say that C is the sum of A and B. What is B? B is the difference of C and A, right? And what is A? A is the difference of C and B. So I'm going, this is what, when you start talking like a mathematician, so you have to define each and every point. So the mathematicians, they needed the definition, what is 2. So they said that we will invent a new method, है ना? इसीलिए तो exceptions नहीं होते हैं. जहां कुछ खत्म हो गया तो वहां कुछ नया इन्वेंट कर दिया, है ना? Then they talk about chemists. They say that everything is exception. Array, we have to deal with 118 elements only. Now we have to complete the rules within the 118 elements. What does the mathematicians know? So what is 2? 2 is the log of 100 to the base 10. This is how they define log. This is how they define log. So what is log? It is simple. Log of 100 to the base 10, it is equal to 2. What is 2? 2 is the log of 100 to the base 10. Now, Hiba, you will remember it like this. 10 square is equal to 100. 10 to the power 2 is equal to 100. Can you remember this? Yes or no? Hiba, Nehra,
Yes, sir.
Salman. Yes, na? 10 to the power 2 is equal to 100. 10 to the power 2 is equal to 100. You remember this? Okay, you remember this. Now, I'm going to derive a few formulas. I'm going to derive a few rules of log, by using this knowledge of log, this knowledge of log that we have just derived. We have just invented log, and we said that we are inventing log to give what is the exponent. So if the exponent is the log of number to the base of the 10. Okay, so 10 2 is the log of 100 to the base 10. Now, Hiba, you will tell me what will be the log of so tell me 10 to the power what will be equal to 10,000. Yes, Hiba, tell me. चार जीरो है ना, तो how much should be x? Hiba, 10 to the power how much is equal to 10,000? Hiba, Nehra, anyone? Arey, Hiba, why are you so silent? Can you say something at least? It feels like you're not even present. मेरी आवाज नहीं जा रही है क्या?
4.
ये एक तो आप ये बताइए इतना लेट क्यों जवाब दिया आपने? अरे यार जवाब ही नहीं दे रही हैं आप तो. यस हिबा,
I was calculating.
हाँ यू प्लीज से देन ना सर आई एम कैलकुलेटिंग, है ना? सो जितना जीरो होता है उतना पावर हो जाता है ना. आई थिंक यू विल नो दिस. ओके फाइन. 4. ओके, नाउ प्लीज tell me and please stop me Hiba if I do anything wrong in terms of mathematics. Okay, simple mathematics. Log of, I can write 10,000 as log of 100 into 100. Yes or no? Tell me. Yes Hiba, can I write this? Okay, can I write 4 as 2 plus 2? Yes Hiba, tell me, can I write it? Now I am just copying this again. Okay, I'm just copying this log to the base 10, 100 into 100. It is equal to, can I write 2 as log 100? And this 2 also as log 100? Yes or no? Tell me, Hiba.
Yes, sir.
No problem. That means, can you see that I have derived the product rule of log? log A into B is equal to log A plus log B. Okay, log A plus log B. I will write log. This is one rule that you have to remember. But the base should be the same base. Okay, so if I will write log, let us write log x. नहीं 10 ही रहने देते हैं, आप लोग को 10 ही इस्तेमाल करना है, 10 ही रहने देते हैं, लेकिन it can be generalized to any of the logs. Log A plus B, sorry, my bad, log A into B, it is equal to log to the base 10 of A plus log base 10 B. Fine, Hiba, any problem? No problem, na?
No, sir.
Again, you see this here, and I'm writing this like this. Log base 10. I can write this as 100 square, yes or no? Can I write this as 100 square?
Yes, sir.
Then I can say now that this is one term, this is another term, and these two terms are same. That means there are 2 times log 100. This will be equal to 2 into log of 100, yes or no? अच्छा
Yes,
वो
sir.
छोड़िए आप, है ना, लिख सकते हैं ना, यानी तो हम ऐसे भी कर सकते थे. I can write 4 as what? I can write 4 as 2 into 2, and I will write one of these two as log of 100 to the base 10. Any problem, Hiba? No problem.
No, sir.
That means you can see now that what is happening. This 2 is coming down. Yes or no? Can you see this? If you
Yes,
have
sir.
anything in the exponent, this will come down. No, it will be multiplied then. Then you can write this. This is the product rule. This is the power rule. The power rule says that log of base 10 a to the power b, it is equal to b times log of the same base. Okay, log of a to the same base and into b. Fine. So these are the two rules: the product rule and the power rule. Okay. Any problem?
No, sir.
No problem. Okay. Now you tell me log of 1 to the base 10, it will be equal to how much? That means 10 to the power how much will be equal to 1, Hiba? 10 to the power x is equal to 1. What is x?
Sir, 0.
0. Very good. है ना? 0. It is equal to 0. Okay. That means, acha, can I write this as log of 100 upon 100? Tell me, yes or no? Can I write this? Log
Yes, sir.
1 I can, and I also I can write 0 as log of 100 minus log of 100. This will also give me 0, yes or no?
Yes, sir.
Then I have got the quotient rule, which says that log of a by b to the base 10, this will be equal to log a minus log b. Any problem, Hiba?
No,
Yes, tell
sir.
me, Hiba. No problem, na? So we have got 3 rules that we are going to remember. Okay. Now you will keep in mind this one term, and you will always refer back to this one, and then you will start there, and you will start to think about logs. Okay. If you get stuck somewhere, then you will start here, and then you will try to visualize everything. And kiski power hai to kya aa raha hai and everything. You will keep this picture in mind always. Okay. Keep this picture in mind. This is going to help you guys. And what about others? Hamza, आपको तो आता है लगता है log. Khalid,
Yes,
Nehra,
sir.
Salman. Everyone is clear? थोड़ा review हो गया log का for all of you. Yes or no? Khalid, Salman.
Yes, sir.
Okay, fine. So I'm just writing the rules, those rules. Okay, I'm writing them. अच्छा wait a second, I don't want to write so many times log, उसके बाद base log rules. So these are the three things that you can remember, है ना? So this is the definition of log, because a to the power 0 is going to give you 1, and a to the power 1 it is going to give you a, है ना? So this is also true. You can see this happening. It is going to give you a to the power 0 is going to give you, it is going to give you what? 1. And this is the product rule, x into y. This is the quotient rule, and this is the power rule. This is the power rule. Then the next thing that you have to do is you have to remember 3 logs only. How many 3 logs? You have to remember 3 logs. So I am giving you those 3 logs. Log of 2, it is equal to 0.30. Log of 3, it is equal to 0.78. Log 4, it is equal to log 5. The first 4 prime numbers, no? And after that you are done. Log 5 is equal to 0.70. This is 48, not 78. Log of 7, it is equal to 0.84. Okay. So these are the things that you have to remember about log. Now these are the things that you have to know about logs and understand about logs. And these are the 4 values that only you have to remember. Only 4 values you have to remember. Okay. And you don't need any log table. Okay, done guys? Tell me. And all of them are base 10. Okay, all of them are base 10. Okay, now. So you will tell me, first of all, what is the log of 1? What is the log of 1? Tell me guys. Log 1. It is equal to how much, Hiba? Hiba बताएंगी. Hiba बताइए. 10 to the power, how much it is equal to 1?
0.
Yes, Hiba. 0. Very good. Now you tell me what is log. You can see and tell what is log 2. What happened? Why so much time, Hiba? Thank you very much.
Sorry,
Tell me
your
log
voice
3.
was quite lagging in between.
Acha, sorry. I am sorry, Hiba. Okay, log with the base 10. What is the log 3 of base 10?
0.48.
Yes, very good. Now you have to use the rules and tell me what is the log 4 base 10. Tell me. How will you write? How will you write log 4? So I'm giving you a hint, Hiba, here. So I can write this log 4 as 2 into 2. Yes or no? Hiba?
Yes, sir.
Now you understand what you have to do?
Yes, sir.
Now you tell me. बताइए. This will be equal to, tell me, log of what?
0.09.
यही तो हम बोल रहे हैं आपको, हम लॉग में बोल रहे हैं ना. बताइए लॉग में, बताइए क्या होगा. यूज द प्रोडक्ट रूल एंड टेल मी ना. टेल मी log a into b is equal to log log x into y is equal to log. अरे यस हिबा, नहीं आ रहा है.
log x plus log y.
हाँ नहीं तो 2 के टर्म्स में बोलिए ना. सो दिस विल बी व्हाट? log 2 into 2 will be equal to
log
log
2 plus log 2.
वेरी गुड. log 2 plus log 2 है ना. ऐसे ही जाइए स्लो स्लो. व्हाट इज log 2? व्हाट इज द वैल्यू ऑफ log 2?
0.30.
0.3 plus 0.3. This will be equal to how much? Equal to
0.9.
how much? 0.9 कैसे हो जाएगा?
0.6.
Thank you very much. Tell me. Log 5. How much is log 5? Yes, Hiba?
0.70.
Now tell me. How can I write log 6? How can I write log 6? As log of what? How will you multiply this 6? Prime factorization कर
Log
दीजिए
3
आप.
into 2.
Very good. Log 3 into 2. And how can I write this? Log 3 into 2 as log?
Log 3 plus log 2.
Very good. Which will be equal to 0.48 plus 0.3,
3.
which will be equal to 0.78. Okay. चलिए. Log 7, log 8, log 9 and log 10 है ना, ये बेस 10 है. तो 10 to the power how much will be equal to 10? हिबा ये बता दीजिए आप, फिर आप कर लीजिएगा 7, 8, 9. Yes, Hiba, tell me. 10 to the power how much it is equal to 10? 10 to the power how much is equal to 10? Yes, Hiba. Arey, what happened? Hiba, can you
Sir,
guys hear
actually
me?
her battery is low, so she's just putting in the plug.
Aha, okay. ये सब आपको आ रहा है ना हमजा? You have no problem,
Yes,
right?
sir. Yes,
Okay,
sir.
fine.
No problem.
Sir, 1.
Very good. है ना? And you calculate these. Okay, 7 का तो हमने बताया ही हुआ है 0.84. So you just calculate for 8 and 9 and then you tell me, okay, in the chat. Others also can write this down.
Sir, everyone has to tell the answer.
नहीं, you can. You can. Otherwise, you can just check. I will write the answers now. Hiba, let me know if you get stuck or something, okay? Done, Hiba?
Yes, sir, done.
Yeah, tell me. Log 8 is how much?
0.9,
Yeah, very good. And log 9 is?
0.96.
Yeah, 0.96. But just a disclaimer that this is more near to 0.95. Okay, it's just that I have approximated this zero. It was actually 0.476 or something, log 3. Let me just check. And I approximated this to 0.48 log 3. And this is 477. Okay. So, and log 9 is more of 0.954. But if you can remember 0.96 also, that is fine. No problem in that. Okay. But please write the correct things in the notebook so that I don't get blamed कि sir ने गलत पढ़ा दिया log. You just write this also 0.95. Okay. Approximately, this is more near to 0.95. Okay. Now, so I hope you are clear till log 10. Yes or no, Hiba?
Yes, sir.
Okay, fine. Now let us look at some logs which are greater number. Let's see. If you have to calculate the log 38. Okay. Log 38. And the base is always, the base will be 10. Okay. The base will be 10. Whenever I am writing log, it will be base 10. So first thing that you have to do is, first thing that you have to do in the solution is to prime factorize. This may seem lengthy because this is the starting, because it's the first time that you are learning log. Hai so prime factorization. So you can do, right? Prime factorization. You will make a column like this. 38 divided by 2, 19, right? So 19 and 2, both of these are prime factors. So I can write 38 as 19 into 2, right? I can write 19 into 2. Now, you can say that I can write log of 38 is equal to log of 19 plus log of 2. So I know the value of log of 2, but I don't know the value of log 19. I cannot even factorize it further. So what we can do here, so this is where we are stuck now. Here we have stuck. Now, whenever you have to, now you have to approximate. So whenever you get a very large prime number, if there is a large prime number, now while calculating log only, then approximate it to next number, not previous number. Whenever, whatever you have, if you have 11, you will approximate it to 12 and not 10. Okay, next number. I will tell you the reason. Next number. And these, whenever you get about approximation, if any teacher tells you about approximation, how to approximate something, that is not science, that is experience. And that is how you are seeing and looking at patterns and how you are approximating. So how I came up with this approximation is this. I just looked at the values of log 1 to 10. Okay, and this is something that I want all of you to observe. If I see the difference between log 0 to log 1 and 2, the difference is of 0.3. If I move further down, the difference here, it is of 0.18. If I move further down, right, if I go from 3 to 4, the difference is of how much? 0.12. Yes or no? From 4.8 to 0.6, right? If I go from 6 to 7, the difference is of
Yes,
0.1. And if I go from 6 to 7, the difference is of 0.6. If I move further down, it is again 0.6, and then there is 0.5, then there is 0.5, right? So I can see that if I gradually go very down, if I increase the number, if I keep increasing the number, then the difference of those values of log is going to get very, very small. It is going to get very, very small. And it is better to, now if I want to approximate, you can see that now 4.8, if I look at 4.8, and if I go down, it is 0.1. The difference is 0.12. If I go above, the difference is 0.18. So in any case, if you have a number,
so it
my
should
voice
be
is lagging.
0.06.
कहाँ पे? हाँ ये
log
सब ये सब
7
हाँ
and
sorry yeah sorry yeah है ना. So I was just making a case that whenever you have to approximate, you just approximate to the next number. Okay, so when you have 19, then you will just write this as log of 38 will be approximately equal to log of 20 plus log of 2 is how much? 0.30. Okay, now we can directly approximate log 20 and you can say that log 20 is how much? Log 20 is 2 into 10. Yes or no? This will be equal to log of now you calculate log 38 in your calculator and tell me what is the value. What is the exact value of log 38?
the 1.57.
1.57 है ना. See, it is very near है ना. It's very near, differences of only 0.03. Okay Hiba, any problem guys? What about others? Now you can calculate log.
Yes, sir.
Yes, okay. Now we will also look at if we have a power of 10 and how to calculate the decimal ones है ना. We will see how to calculate the decimals one. So first write this down, let me know if you're done.
Done, sir.
All of you, yes or no? All of you are done? Okay. So what I'm doing, I'm just calculate log of 3.8. Okay, so I'm not taking any new number, I'm just putting a decimal point here, 3.8. So what you need to do here, first of all, you will, in this case, the solution is to rewrite as some whole number x into, let me write w into, because of whole number, some whole number into 10 to the power minus something, minus x. So 3.8. So how will you write 3.8? I will write 3.8 as 38 into 10 to the power minus 1. And then I will calculate the log. So I will write log of 38 into 10 to the power minus 1. This will be equal to log of 38 into, sorry, not into, plus log of 10 to the power minus 1. And log of 38, I have just calculated, it is 1.6 plus log of 10 to the power minus 1. Now, so what I can see, this is a power and it will come down. So with the sign, it will come down. So minus 1 times log 10. Okay, and this will be equal to 1.6 plus minus will be minus, log of 10 is equal to 1, and this will be equal to 0.6. So write this down, let me know if you're done. You understood the Seba now? How to write, how to do things? Yes or no? For
Yes, sir.
decimals also? Okay, fine. Please write this down, guys. Let me know if you're done. Okay, so this is all for today. And tomorrow, what we are going to learn now? Tomorrow, we are going to learn how will we calculate 10 to the power x is equal to, let us say something, that 10 to the power x